Introducing CelebA2Image, a cutting-edge text-to-image generation project that brings the textual descriptions to life. Our project combines the power of advanced AI techniques, including natural language processing and deep learning, to seamlessly transform the words into stunning images. So whether you're an artist, designer, researcher, developer, or even a content creator, this project empowers you to visualize your ideas effortlessly. Simply just describe the attributes you want in your image, hit generate, and watch as our AI generates a high quality image that closely matches the description. Right, so the project is a text to image generation system that obviously converts the textual descriptions into visual images. It leverages the CelebA dataset that comprises over 200,000 annotated images, and the system employs a powerful generative adversarial network, which is also known as a GAN, consisting of a discriminator and a generator. So in this project, we have incorporated a CGAN, which is basically a conditional generative adversarial network, and it takes the advantage of the labels during the training process. So in the slide, you can see we have a generator and a discriminator. So the discriminator acts as a judge by evaluating whether the generated image is real or fake. And meanwhile, the generator's task is to produce images upon the user's input that can deceive the discriminator into believing that they are real. So it's an iterative process, and through this process, these two components engage in a fierce competition, continually improving the quality of the generated images. So here we have a screenshot of our user-friendly GUI, and here we have our image generation process depicted as a picture. Right, so let's move on to the demonstration of the project. So here we have two Python files. One is a GUI file, the other one is a Jupyter Notebook file, which is used to train the GAN model. So this Jupyter file saves the GAN model, and we have a bunch of different functions here to pre-process the image, to initialize the GAN architecture, and to load the dataset. So let's move on to the GUI. Let's see how it works first. It's a bit slow. Oops. Yeah, right there. So let's enter any prompt. Right, so the generator tries to accurately generate the image. Of course, it's not the most accurate image out there because the generator has only been trained on 100 epochs as of now. Let's see how it works. So right now, the main game loop, it prompts the user to enter the input gets pre-processed, gets converted into text encodings using the universal sentence encoder, and then the generate image function is called, which creates the final attribute vector using the compare to attributes function. In this compare to attributes function, it just compares all of these attribute descriptions with the input text and converts them into encodings using universal sentence encoder as well, and then the similarity for each attribute description is calculated using cosine similarity, and then the similarity of the attribute description that's the most similar gets chosen. And we have also incorporated a threshold value of 0.35, so the value to be chosen has to exceed 0.35 cosine similarity, and we are using argmax to fetch the index value, and then we create the final attribute vector, and then this vector gets passed back to the generate image function, and then it gets concatenated with our noise vector, and then it serves as the input for our generator to predict the image.